Hello everybody, my name is Ewan and welcome to a Unity tutorial. Today we're going to be making a very simple 2D top-down controller. Essentially all it's going to be doing is we're going to put a pixel on the screen, we're going to give it a nice color and a nice background. We'll be able to move it around and I'll show you how to set up some basic collisions. We're going to be doing this using Rigid Body 2Ds, a built-in function that come with those, and just regular old 2D colliders for those collisions that we were talking about. And you're going to see how we'll very simply turn a sprite into a smooth and responsive controller. The only prerequisite you need for this is a Unity install. I'm currently using 2020.1.3f1 to get this nice new dark theme. And provided down in the description below will simply be this pixel.png. This is just a 16 by 16 sprite in a white color. It's a really nice resource to have when you're doing 2D stuff. Unity doesn't come with any just straight square pixel like this, so we'll import this into the scene and we'll be using this for most of our background. I already have this exported here onto my desktop, so I'll just go ahead and drag that in here real quick. Again, it's going to be pixel.png. I'm just going to drag this into my project folder. Throughout these series, I'll be showing you some really nice conventions here and good ways of organizing your projects. So the first thing we're going to do is just create a folder here and call it sprites. Since we don't have any other sprites at the moment, that's about as much as organization as we'll do. So I'll just drag that in there and we'll set up some quick settings. So this sprite, like I said, is 16 by 16. So we're going to set pixels per unit to 16. And we're going to come down here to our filter mode and set it to point so Unity doesn't try and blur it out and blend the lines. I also set compression to none, but that's just personal preference. Awesome, now that we have our sprite here, we can click on our game scene and see that we have nothing in here. The first thing I'm going to do is click on our main camera in the hierarchy and change the background color to something that's not quite so ugly. I like the hexadecimal value of EA, just a nice ivory color. You can set that to whatever you want. Again, it's personal preference. Next thing we're going to do is right click in the hierarchy and create a 2D object, go to sprite. We're just going to name this player over here in the inspector and change the color to a nice pink. We're going to reset the transform here by right clicking and clicking reset. If we go to our game now, we can see that it's not showing up. The reason for that is we haven't yet used our pixel here. So we're going to go to the sprite under sprite renderer and just choose pixel. And as you can see, we have a nice sprite. It's just a very simple square in the center of our screen. From here, we can go back to our assets folder here, right click, and we're going to create a folder. We're going to call it scripts. And we're going to right click again, create C# script. We'll just call it player movement. Double click to open that up in Visual Studio. Okay, now that we're in Visual Studio, this is just a force habit for me. I'm going to delete both of these starting methods here and delete these top two using lines. Very simple to do. It's a very good practice and to not incorporate things that you're not going to use. It slows your project down as it gets bigger, has a lot of bloat and other things that you just don't need to keep around. So we're going to make a couple of variables up here. We're going to make a public float. We'll just call it speed. We'll set that to a default like 3. We're going to get a private reference to the Rigid Body 2D component, which we'll be using to actually do the movement. I'm just going to call that RB. Then we're also going to have a private vector2. We're going to call that movement. So the rigid body is just the 2D physics object that Unity uses. And the vector2 is going to store our input in an X and Y direction. If you look up the vector2 documentation, you'll be able to find some things about that and different ways to use that. It's just a 2D representation of our movement input. Next down here, we're going to type in void update. Essentially what we're going to do here is get our input. Unity has some default axes set up that work very well for this purpose. So we're just going to say movement.x. This is just going to be our movement on the x-axis. We're going to set that equal to input.getAxis raw. This is just going to return the no smoothing axis. And the axis for horizontal movement is simply just called horizontal, spelt exactly that way. And now we're going to get our input on our Y, so our up and down. And as you can probably guess by now, it's going to be movement.y. We're going to set that also equal to input.getAxis raw. And up and down is vertical, spelt vertical, just like that. Awesome. Okay, so now we're going to apply the actual physics movement. A good practice in Unity is not to apply physics movement in a regular void update, but rather to go below it or wherever else in your script and do a void fixed update. That's just the way that physics work with Unity. This is the most performant and best way to really apply these movements. So from here, Unity makes this very easy. We can do RB, which is a reference to our rigid body 2D, dot move position. Again, this is just a really nice built-in function that Unity gives us. So what we're going to do is we're going to get our local position. So we're going to do rb.position. So we're getting the position of the rigid body game object. We're going to add our movement input. We're going to multiply that by our move speed, or our speed rather. And then we're going to multiply that by time.fixed delta time. And essentially what this fixed delta time does is it stops the movement calculation from being dependent on frame rate. So if we were to remove this, a computer with 1,000 frames per second would move much faster than a computer that could only manage 100 frames per second. So it's important to keep this in mind when doing math and movement calculations in a game. As far as movement, that's the only line we're going to need. But we need to keep something in mind as far as our rigid body 2D. So because we've made this private, which is a great practice, we're going to need to get a declaration for it in the script. So what we can do is we can type in void awake. This is called when the script is first initialized. We can say RB equals get component. We can put rigid body 2D in here because that's the type of component that we're going to need. And it'll be a good idea to keep an eye on the syntax here, as this is what Unity uses for getting components. So what essentially this is going to do is it's going to say our rigid body 2D is equal to the rigid body 2D that's on this game object that player movement script is on. So awesome. Now that we have that all set up, we can save it. We can go back into Unity, wait for that to compile, and then we can click on our player and drag our player movement script onto it. As you can see here, it showed up there. We have that public float speed, so it's set to 3. We'll test that out. But you might be saying we're missing a component. That's correct. We need to add a component and put rigid body 2D on there. We're going to have to set our gravity scale here to 0, simply because Unity assumes that this is our ground plane and this is our up and down. But in a top-down application, we don't want gravity to be applied on it downwards. We just want no gravity. So think of it as everything's floating in space and there's no downward forces. At that point, the only other component we're going to need, we'll just collapse that. It's going to be a box collider 2D. Very simple. We'll go over to our scene view and make sure that this little green outline here is the appropriate shape. Awesome. Now that we have that, we can click on our play button here. And now our WA, S, and D keys will move this around the screen, as will our arrow keys because of the default Unity axis that we were using. Next, we can just move on to collisions. So as you saw, we put a box collider 2D on our character here. What we're going to do now is just going to right click 2D object sprite. We're just going to call this wall. We're going to do the same thing as we did with our player, set the sprite to the pixel. We'll just make this a nice dark gray. We'll extend it a little bit here and just place it over in the scene. Next, we want to add a box collider 2D. Again, verify that this nice green line goes around the extents that we want, and that is as easy as it is. You don't need any physics component, as this isn't anything that needs to get pushed around. And now, as you can see, we cannot go into this wall. But we have run into an issue. Once we pull ourselves off of this wall, it starts us spinning. This is a physics object, our player is a physics object. So it's very simple to actually fix that. We just unplay the game, go over to our player. And the rigid body 2D component has this wonderful section called constraints, and we can simply freeze our rotation on the Z axis. Now if we play, we can still collide with the wall, and when we come off of this bottom bit, it just simply doesn't rotate us. So with that, we now have a basic 2D camera controller, and next tutorial we'll be setting up Cinemachine, as it gives you a really nice smooth camera follow, and we'll be moving on from there. If you found this tutorial useful, make sure you hit the subscribe button, hit like, it really helps with the channel. Leave a comment if you have any questions or suggestions for further tutorials, and I'll see you guys in the next one. Thank you.